This video is about solving equations and inequalities. And this video is designed for intermediate algebra. So I'm expecting that you are already familiar with some of the basics of solving equations and inequalities. Those are things you should have done in algebra. So I'm not going to cover every single little detail, but just do a quick review of some of the basic things that will be really important in our course. All right, so if there are things that you don't understand, please talk to your teacher in class about that. Alright, so we're going to solve this equation, and we also, after we solve it, we're going to graph the solutions. Alright, so to start off, we're going to solve for x. We're going to isolate x, get x by itself. So first I'm going to subtract 7 from both sides. I'm going to have x over 4 is equal to negative 5. Alright, so next I'm going to multiply both sides by 4, right, which is the same thing as 4 over 1. On the left, these 4s will divide out. 4 divided by 4 is 1. So I have x is equal to negative 20. Alright, so that's our solution. The number that would make that equation true is negative 20. And actually, I should say one other thing about that. Right? So what does this mean? Right? So our solution is negative 20 because negative 20 would make our original equation true. Right? If I were to plug that in to the beginning equation, right, our original equation was x over 4 plus 7 is equal to 2. If I were to replace that x with negative 20, right, that would give me negative 5 plus 7 is equal to 2, which gives me 2 is equal to 2, which is true. Right? So remember that negative 20, that's the solution, meaning that's the number that would make our equation true. Alright, so last thing, let's graph the solution. Right, and this was from our previous video. We talked about how to graph these. Let's maybe count by 5s. Alright, so our solution is negative 20. So it's closed dot right there at negative 20. Alright, this one I have 17 is greater than 3x minus 7 plus 2x minus 1. Right, and something like this, you always want to simplify everything you can before you start to do things to both sides. So I'm going to combine my 3x here with this positive 2x. That's going to give me 5x. And I can also combine the negative 7 with this minus 1, which gives me minus 8. Okay, I'm going to bring this 17 is greater than down. So I have 17 is greater than 5x minus 8. Okay, now let's start to solve this. I'm going to add 8 to both sides. That gives me 25 is greater than 5x. Right, and one more step to get x by itself. I'm going to divide both sides by 5. And I get 5 is greater than x. Okay, so that's ready to graph. Right? Let's think about what all the solutions of this would look like. Right? So let's first set up our number line. Oops. Alright, so first let's check our boundary value. Alright, is 5 a solution? Well, if I were to place x with 5, 5 is greater than 5. That's false. Right? So our boundary value of 5 is not a solution. So I'm going to use an open circle here at 5. And let's think about what numbers would make that true. 5 is greater than 5. Right? It's going to be numbers over to the left. Right? So if numbers over in this boundary over here. Right? If I were to use a number like 4, 5 is greater than 4. Replace the x with 4. 5 is greater than 4. That's true, right? All of these numbers to the left of the boundary are going to make the inequality true. Right? And all of these numbers over here would not be true if I were to plug it in, right? 5 is not greater than 7. That's false. Right. One other thing I should mention on this, it is totally fine if you want to rewrite this answer here in a different way. Right? You could also write that this way. 5 is greater than x is the same thing as saying x is less than 5. Right? So either this or this would be acceptable answers. And they both have the same graph, same solutions. Alright, this one, 5 minus 3 times the quantity x minus 4 is less than or equal to 41. Right? Again, let's simplify. And for this one, I'm going to simplify by distributing this negative 3. So I have 5. This is going to be minus 3x plus 12 is less than or equal to 41. Right, now I'm going to continue to simplify by combining this 5 and 12. That gives me 17 minus 3x is less than or equal to 41. Okay, I'm going to continue. I'm going to subtract both sides by 17. Right, and I have negative 3x is less than or equal to 24. Alright, one more step here. I'm going to divide both sides by negative 3. Okay, now here's a very important thing for you to remember. Alright, right here, when I divide by a negative number, right, that is going to make me need to reverse my inequality symbol. Right, so instead of being less than or equal to, this is going to become greater than or equal to. Right, so this is an important thing you should have learned in algebra. Right, remember, whenever you multiply or divide both sides by a negative number, the inequality symbol needs to reverse. So it changed from less than or equal to, became greater than or equal to. Right, that only happens when you multiply or divide both sides by a negative number. Okay, so let's graph our solution. X is greater than or equal to negative 8. Let's graph the solutions to that statement. And let's count by 2's. Okay, let's start with our boundary. Let's always start with your boundary. Let's see. Negative 8. If I were to use negative 8 in that inequality, would that be true? Negative 8 is greater than or equal to negative 8? Yeah, that's true. All right, so our boundary, negative 8, is a solution, so I'm going to use a closed circle right here. Let's think about what numbers would make this statement here true. Right, well, those would be all the numbers that are greater than negative 8. Right, numbers like, let's say, negative 4. Negative 4 is greater than or equal to negative 8. Yeah, that's true. Right, so all of these numbers over here to the right of the boundary are solutions. Let's shade those in. Right, and all the numbers to the left of the boundary would not make it true. For example, negative 12 is greater than or equal to negative 8. Well, that's false. Right, so that's why these are not shaded in over here. All right, for number 4, I want you to do this one on your own. So please pause the video, solve the inequality, and then graph your solutions. All right, you should have done that by now. Let's see if you got the right answer. All right, I'm going to start by simplifying the left-hand side. I'm going to distribute. You can think of this as having a negative 1 here. So I'm going to distribute a negative 1. That's going to give me negative 3 minus x plus 7 minus 2x is less than or equal to 25. All right, let's combine things on the left. So I can combine negative x with negative 2x. That's negative 3x. I can combine negative 3 and positive 7 to be positive 4. Okay, and let's continue here. I'm going to subtract 4 from both sides. So I have negative 3x is less than or equal to 21. And I need to divide both sides by negative 3. So I have x on the left. On the right, I'm going to have negative 7. 21 divided by negative 3 is negative 7. All right, double check here. Did you reverse the inequality? You do need to reverse the inequality, right? Because I divided both sides by a negative number. So it needs a reverse from less than or equal to become greater than or equal to. All right, so our answer is x is greater than or equal to negative 7. And let's do the graph of all the solutions to that. All right, our boundary value of negative 7 is a solution, right? Because negative 7 is greater than or equal to negative 7. That is true. Right, so negative 7 is a solution. I'm going to use a closed circle. Okay, and where are the solutions? Well, those would be numbers, in this case, to the right. These numbers, for example, like negative 4 here. Negative 4 is greater than or equal to negative 7. That is true. Right, so our solutions should be all the numbers to the right. Alright, here's our last one. Again, I want you to do this one on your own. Alright, so please pause the video, solve it, and graph it. Alright, let's see how you did on this. Alright, let's start by simplifying the right. So I'm going to have 6x minus 10 is less than, those will combine to become positive 2x minus 44. Alright, I'm going to subtract 2x from both sides. That's going to give me 4x minus 10 is less than negative 44. Alright, I'm going to add 10 to both sides. So I have 4x is less than negative 34. Alright, here I need to divide both sides by 4. Okay, there's some really important things here that you need to pay attention to. Right, on the left, I have x is less than. On the left, I have x, and in the middle, this inequality does not need to be reversed. Right, I divided by a positive number. Right, you only need to reverse it when you divide or multiply both sides by a negative. Let me say that again. Only when you multiply or divide by negative. Right, so we divided by a positive. Even though there's a negative in the problem, right, we divided by a positive. So this is going to stay less than here. Okay, and then right here, negative 34 over 4, that can be reduced. That's the same thing as negative 17 over 2. Right, and you might be thinking, right, how would we graph x is less than negative 17 over 2? How would we graph the solutions to that? Well, in this case, it's probably easier to think of negative 17 over 2 as a mixed number. Right, this is the same thing as saying x is less than negative 8.5. Right, because 17 over 2 is the same thing as 8.5. Right, so now that's a lot easier to think about. All right, let's set up our number line. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Right, so where is negative 8.5? Well, that's going to be halfway in between negative 8 and negative 9. So that is right here. Okay, so we want to graph the solutions to x is less than negative 8.5. Well, let's start with our boundary value. Right? Is negative 8.5 a solution? Right, so if I were to replace x with negative 8.5, I would have negative 8.5 is less than negative 8.5. Is that true? No, that's false. Okay, so negative 8.5 is not a solution. Right? Let's use an open circle here. Right? Where would the solutions be? Well, those would be the numbers that are less than negative 8.5. Right? Numbers like negative 9. Negative 9 is less than negative 8.5. Yep, that's true. So I'm going to shade all the numbers that are to the left or less than negative 8.5. Right? And there you have the graph of our solutions.